Okay, this is topic 41, the first derivative test. So now we're going to talk about critical values, all right? And a critical value is defined when either the derivative is equal to 0 or whenever the derivative is undefined or does not exist. Okay, so again, the critical value is defined at the point where the derivative is equal to 0 or the derivative is undefined. All right, so if we jump down to example number 1, all right, on number 1, they're asking us to find the critical value. So therefore, the first thing I have to do, all right, I have to take the derivative. So I'm going to take the derivative of f, and that's going to give me 1/3 x to the negative 2/3. And if I simplify this a little bit more, you would have 1/3 x to the 2/3. Okay. So at that point, what I want to do with this is I want to find out my critical values are located possibly in two different places. They're located where the derivative is equal to 0. I want to find that x value. So therefore, I'm going to set my derivative equal to 0. And I'm going to set that equal to 0 and solve. All right, now to solve this, you would either multiply both sides times the denominator, or I would cross multiply. However you want to do it, it's fine. Now on this one, you'll find out that you're going to get 0 is equal to 1, all right, which is not true. So therefore, there is not an x value where the derivative is equal to 0. Okay, so we don't have a critical value there. However, if I set my derivative equals to d and e does not exist or undefined, okay, then I'm going to try to figure out if there's a point on f where my derivative is undefined. All right, so to do that again, I'm going to set my derivative equal to, really you can set it equal to 1/0 if you like. I like to do that sometimes. I'm not really sure that it works every time, all right, but if I cross multiply, I would get this, which implies that x is equal to 0, right? So if you work this out, you'll find out that x is equal to 0, and that would be easy to tell me even at this point. If I plug in a 0 for x, right, I cannot divide by 0, so therefore, at x is equal to 0, my derivative is undefined. So, therefore, I did find one. My critical value is located at x is equal to 0. And obviously, you can probably have, not probably, you can have more than one critical value, all right? I'm going to show you why that critical value is important. So, at that critical value, you may have an instance where you have a max or min. Right now, to figure out my maximum and minimum, what I'm going to do is I am going to draw a line here, and I'm going to write it between -8 and +8. I'm going to draw a line to do sign analysis. I'm going to put all my critical values into this number line. All right, and now what I want to do is I want to choose a point to the left of 0 and figure out if that value, when I plug it into the derivative, is equal to a positive value or a negative value. All right, so think about it. If I were, let me cancel this. I don't necessarily recommend using a calculator, but I want to make sure you understand what I'm trying to say. If I plug in a -1, which is a number to the left of 0, and I raise that to the power of 2 divided by 3. All right, I hope that you don't need a calculator for this, but remember, if I have a -1 and I square it, I get a +1. And if I take the cube root of 1, I still get a +1. All right, this is going to be 1/3. So it doesn't matter what the number is so much as the fact that this is a positive number. So therefore, for my sign analysis, this is going to be positive, and a number to the right of 0, I'm going to pick a 1, and if I pick 1, this is also going to give me a positive 1/3. Right, but what matters is that you have a positive value. All right, now that I have a positive value, my question is, where do you have a max or min? Now, if you look at this, a maximum or a minimum is located when the sign of the derivative changes. And in this case, the sign never changed. I stayed positive the whole time. So therefore, in this problem, I have no maximum or minimum. I don't have a maximum nor a minimum in this one, all right? So on C, for question part C, they're asking me for the intervals where where f is increasing, all right, and where is it decreasing? So I'm increasing, and the whole reason to do this also, besides that it helps me to find a maximum or a minimum, this also helps me to find out if my graph of f is increasing or decreasing. Now if you look at the sign analysis, the derivatives are positive, which means I'm always increasing. All right, so I'm actually increasing between -8 and +8. Okay, because the derivative the whole time is positive, right? So if the derivative is positive, I'm increasing the whole way. Okay, so now on part D, they're asking us to find a value of C, a constant. They're asking us to find an x value that satisfies the mean value theorem. Now, if you don't know what the mean value theorem, I recommend you go back to lesson 40 and find that out, right? But there was two conditions that I need to meet in order for me to find the mean value theorem. I have to make sure that f of x is continuous between -8 and +8, including those two endpoints. All right, so I need to figure out if this is continuous. And if you look at the graph of this, it is. But also, if you don't have a calculator, think about it. You can plug in any number for this x, and you will get a y value back. Any x value will give you a y value. It doesn't matter what you put in there. You can put a negative, a positive, a large number, a small number. There's nothing you can put on here that does not give you back a y value. So therefore, it is continuous. All right, so you don't really have to write more than that. That would take a little while if you did that. All right, now I also need to make sure that f of x is differentiable between -8 and 8. Okay, notice that I'm not including the endpoints. I need to make sure that it's differentiable between -8 and +8. Now, on this one, we actually already know this because at the beginning, we figured this out, all right? If this is true, which that means that I have a point where f of x is undefined, that means that this right here is not differentiable. This is not differentiable between -8 and 8, okay? Because I found one point, which is x is equal to 0, where the derivative does not exist, all right? So again, this is not differentiable. At x is equal to 0. Because there is a vertical tangent. Now you may not know that, but that's kind of what happened here, right? If I have an undefined, I could possibly have a vertical tangent. It's not always like this, but in the case of this function, I do have a vertical tangent. At this point, I can actually show you the graph of x to the 1/3 power plus 1, and that's what that looks like. And you can actually tell that at this point right here, at x is equal to 0, you have a vertical tangent, okay? So just be aware of that. You may use the calculator, but you should also have enough mathematical knowledge to figure this out without it, all right? Especially in this problem. Not all of them, but this problem you could definitely not use a calculator. It's not necessary. All right, now if I go to the back, I'm going to do the same thing. We're going to find the same thing. So I'm trying to figure out the critical values. Now remember that my critical values are located where my derivative is equal to 0 or where the derivative is undefined. So the derivative right here of this one would be 1 minus 2 cosine of x. All right, and then now to figure out my critical values, I am going to have to set my derivative equal to 0, okay? And like we talked about in the past, if you have that, then you could possibly have a max or min or neither, but at least that's one of them, all right? At least you can find out. So now I'm going to set my derivative equal to 0. Okay, and if I set my derivative equal to 0, I'm going to try to solve for x. So if I subtract the 1 from both sides, and if I divide both sides by -2, I would get the cosine of x is equal to 1/2. Now again, you should not need to use a calculator in this. And now all you have to think about is, where is the cosine of x equal to 1/2? Alright, so hopefully you find out that this is, that this happens at pi over 3. And remember, because this is positive, you also have a cosine that's equal to 1/2 in the fourth quadrant, which will make this 5 pi over 3. Right, so again, make sure you review your trig for this. Right, also, as I'm finished with this part, now I have to figure out where is the derivative undefined. Or does not exist. I have to figure that out. Now for this one, it's kind of useful to understand that if you're looking at the graph of g of x, right? If you're looking at the graph of g of x, is there any point on this, especially with the sine part, where you have a sharp point or a cusp, or where you also have, or you could also possibly have a vertical tangent? Now if you think about what the sine function looks like, that never happens. On the sine function, you don't have any sharp points or cusp, and you don't have any vertical tangent. So therefore, this one is a none, right? There's not a point where the derivative is not defined. All right. So now this is the A part here. The B part, I'm supposed to figure out my max and mins, and I'm going to do that by doing some sign analysis. And in this case, I'm going to do some sign analysis between 0 and 2 pi. And I'm going to put on here all my critical values, which in this case were pi over 3. And this is 5 pi over 3. Okay, now again, I want to think of numbers between 0 and pi over 3. And I'm going to plug this in. For the sign analysis of the derivative, I'm going to plug that in back into the derivative function. All right, so I'm going to plug this back into the original. So if you think of something like pi over 4, for example, all right, this is just an exercise for you. If I plug in a pi over 4 for that, and again, I'm going to use the calculator, but you shouldn't have to. I'm just doing this for the ones that are watching this on video. So you should know what that is, but if you don't, all right, so if I pick something like pi over 6, I would have 2 cosine of pi over 6. Now, Now cosine of pi over 6 is the square root of 3 over 2. Okay, so which is basically going to be a negative number. Alright, so you would have 1 minus the square root of 3, which is that. Alright, the point is that this is a negative number. Right, this is a negative number, so therefore you have a negative. Now once you figure that out, I mean, look at it. This is a cosine function. What do you think it's going to do? It's probably going to do this. It's going to have maximum and minimums, right? It's going to go up and down, up and down. Now, again, if you didn't know that, but even if you don't have that knowledge, pick a point between pi over 3 and 5 pi over 3, such as pi. If you plug in a pi here, cosine of pi is negative 1. Negative 1 times negative 2 is positive 2. 2 plus 1 is 3, so that will make that a positive, right? So that's how you found those. You have to do some sign analysis and pick some points to the left and points to the right and plug them back into the derivative to figure out if the value is going to be positive or negative. All right. So my maximum on this one, notice that my maximum on this one, I'm going from positive to negative. There's a sign change, and because of that, my maximum is going to be located at 5 pi over 3. And this is a maximum because g prime of x goes from positive to negative. Alright, my minimum, same idea. There's a minimum of pi over 3, and that's because g prime of x goes from negative to positive. Okay, so notice that's the same thing, it's just backwards, right? The explanation is just that. Okay, so on the C part, they're asking me, where is this increasing, right? So to figure out where it's increasing, you can tell just by the sign analysis. I know that g of x is going to be increasing. Remember, I'm talking about g of x. G of x is going to be increasing. If I look at the derivative is positive, which means I'm increasing between pi over 3 and 5 pi over 3. Okay. Now I'm decreasing in two different spots here. I'm decreasing between those two, right? You can tell if the derivative is negative, then g of x is going to be decreasing here and here. So it's going to be decreasing between 0 and pi over 3 and between 5 pi over 3 and 2 pi. Okay. Now finally at the end, I'm going to try to find a c value that satisfies the mean value theorem if it exists. So remember, first thing I have to do is I have to figure out if g of x is continuous between 0 and 2 pi, including 0 and 2 pi. So if I go back to this one, if you think of the sine function, it is continuous. There is no breaks. It is continuous. So, and the question now is it differentiable? And if you would want to, you can graph this on your calculator. However, if you think of the sine function, can you think anywhere on the sine function where you would have either a sharp point, a cusp, or a vertical tangent? And hopefully the answer is no, right? So this one is differentiable, right? So this one is also differentiable. Now, because I meet those two conditions, and therefore I can do the mean value theorem, right? The mean value theorem says that there's a x value or a c value. There's a value where the derivative is going to be equal to the slope of the secant line between the two endpoints. Alright, so again, if you haven't seen that video of the mean value theorem, where you can just look up mean value theorem, this part right here is just the slope formula. It's the slope formula between 2 points. Now those 2 points happen to be the endpoints. Alright, so this is just the slope formula between the endpoints. Alright, so now what I'm going to do is I'm going to set the derivative, which I found on part A. I'm going to set that equal to, well, what is g of 2 pi? I'm sorry. G of 2 pi, I would have to plug in a 2 pi here and a 2 pi there. Now that will give me 2 pi. May write it over here just once. G of 2 pi will be 2 pi minus 2 sine of 2 pi. Now hopefully you know that the sine of 2 pi is 0. So all of this is 0. So that's just going to be 2 pi. So g of 2 pi is just going to be 2 pi. Now similarly, if you plug in a 0, you're going to have 0 minus 2 sine of 0, and sine of 0 is 0. So that's what I'm going to get for the top, and this bottom part, well, I'm just going to leave it alone. Notice that I have 2 pi, basically 2 pi divided by 2 pi, which is 1. So this is 1. I'm going to subtract the 1 now. When I subtract 1, I get 0. I'll make it a 0, and then now if I divide both sides by negative 2, I still have the cosine of x is equal to 0. And then now I just have to figure out where is the cosine of x equal to 0. Right, and hopefully it won't take you too long to figure out the answer. The cosine of x, the cosine of pi over 2 is 0, and the cosine of 3 pi over 2 is also 0. So at those 2 points satisfies the mean value theorem. Okay, so at those 2 points, the derivative is the derivative of pi over 2 and the derivative of 3 pi over 2 is the same as equal to the slope of the secant line between the two endpoints. Okay, so hopefully that makes sense. If you got any questions, let me know.